Hello and welcome to our presentation. My name is Daniel Borken and I'm a software engineer from Jigsaw and Google. I'll be the first of four presenters for this talk, Next Generation of Perspective, Multilingual Large Language Models and Combating Online Harassment. Just a warning before we get started, this talk contains examples of toxicity. So who are we? Our team, Conversation AI, aims to protect voices in conversation. We are a part of Jigsaw, which is a unit within Google. Jigsaw researches emerging threats that are developing online, and we build technology to address these problems. Today, I'll also be joined by my colleagues Alyssa Lees, Lucas dos Santos, and Rachel Rosen. One of our team's most popular products is the Perspective API. This API uses machine learning models to detect toxicity. Users can enter a comment and receive a score between 0 and 1, which represents how likely it is that the comment will be perceived as toxic. It is used for comment moderation by publishers like the New York Times and El País. It can also be used to provide feedback to users before they submit a comment. In addition to developing our Perspective API, our team publishes research and open source datasets related to the work in combating toxicity using machine learning. I'll highlight just a few of our recent papers in this space. Our team is especially concerned with measuring and mitigating bias. Unfortunately, early versions of our models showed significant biases towards different identity terms. We've developed new metrics for detecting this type of bias, along with ways to mitigate bias, and we have since been able to improve our models. We've published this paper detailing our new metrics. In 2021, we published new work on covertly toxic comments. These are comments that models and raters may have trouble detecting because they use obfuscation or sarcasm, for example. We released a new dataset labeled for different types of covert toxicity along with this paper. We've invested significantly into understanding data annotation. This paper establishes a framework for documenting decisions made during dataset creation in order to provide transparency and to account for ethical considerations when working with crowd raters. For example, how an annotator's identity influences their decisions. Our team has also contributed to research on how to measure model uncertainty. This work enables our models to detect out-of-domain examples. By measuring uncertainty, we can better help users to understand model scores and help with finding new data that needs to be labeled for active learning. In addition to this talk, we have another paper being presented by our teammate Alyssa Shavasta at this conference. This work is called Lost in Distillation, and it explores the hidden costs in model distillation. This research helped to motivate the large language model efforts I'll be discussing later. Jigsaw has also expanded modeling to explore associated toxicity tasks, such as misogyny detection. Our top performing model for identifying Italian misogyny at Evalita 2020 is outlined in this work. It is one of the first publications referencing Perspective's pre-trained proprietary comment domain model. Similarly, Jigsaw has expanded our investment in misogyny research by assisting in assembling a misogyny and memes dataset and hosting the MAMI, or Multimedia Automatic Misogyny Identification Semi-Val task. The results from this competition are being discussed at the Semi-Val workshop, which is co-located with NACL and the WOAH workshop. In addition to publishing research, we host Kaggle competitions, for example, to build models that reduce bias or generalize well across languages. As part of these competitions, we've released datasets like Civil Comments, which contains over 2 million comments labeled for toxicity, with 22% of them also labeled for identity, and is the largest open source dataset of its kind. Our team has released new tools built using the Perspective API to combat toxicity online. For example, Tune is an experimental Chrome extension that lets users set a custom threshold for how much toxicity they are willing to see in online comments. It works with sites including YouTube, Facebook, Twitter, and Reddit. We've also built open source software to help moderators identify and reduce toxicity in their own forums. And most recently, we've built a new tool for reporting harassment, which Rachel and Lucas will discuss in detail later. Now I'd like to talk about some big improvements we've made recently in releasing multilingual large language models. In the past year, we've published a new model that added support for 10 new languages, along with improved metrics in some key areas for our existing languages. This is a preview of research that will be presented at the KDD conference in August. First, I'd like to talk about the previous generation of perspective models. We build our models using real online comments. For our V1 models, we pre-trained our transformer models using 3.5 billion comments representing over 100 languages. For fine-tuning, our label data consisted of online comments shared with us by news publishers and discussion forums. We also included comments that had been sent to our API with permission. For some languages, we are able to include translated comments to augment our training. Lastly, we always include text from Wikipedia to help with bias mitigation. Our comments have been annotated for toxicity, severe toxicity, insult, threat, identity attack, and profanity. Each comment is annotated by at least 5 raters who are fluent in the given language. For training and eval, we set each label based on the percentage of raters who said the comment contains that given attribute. So for example, if 3 out of 5 raters say a comment is an insult, we set the insult label to 0.6. In earlier generations of perspective, we had built both CNNs and transformer-based models like BERT. Transformer models are far more complex. They perform more accurately and can handle more complex and nuanced comments. However, that comes at a cost of higher memory usage and higher latency. Because of the high latency and memory usage of our BERT models, we needed to distill them into CNNs in order to be usable in our production API. To do this, we had our multilingual BERT model act as a teacher model, where it would score millions of unlabeled comments. These comments with their scores from BERT would then be used as training data to our CNNs, known as our student models. These CNNs were what we actually served on our production API. Although our BERT model was supported multiple languages, each CNN was trained on data for only a single language, as these models were not large enough to accurately handle multiple languages. We test our models using a variety of metrics. Our primary metric is ROC-AUC, which we evaluate using a holdout test set of real online comments. We expect an AUC of at least 0.9 for our established languages, but will accept greater than 0.8 for languages that are new to us. We also measure all of our models for bias towards identity terms. This is done using synthetic sentence templates. For example, we create sentences like I am followed by an identity term and I hate followed by that same term. The first sentence should always be non-toxic, while the second sentence should always be toxic. We use our custom AUC-based bias metrics to check how the model handles comments for each identity term, compared with how it handles the overall dataset. Last, we check that the model is able to recall extremely toxic comments using different thresholds to ensure that our model is calibrated correctly. When we run inference for our production API traffic, we first use a separate model to detect the comments language. We then route to a monolingual CNN based on what language we detect to be most likely, or in some cases, if we don't support that language, we return an error. We need to be able to run inference quickly, as customers depend on our API for scenarios like giving authors feedback as they type comments, or the tune extension, which dynamically hides and shows comments in real time. Although this approach helped us build toxicity models in several languages, it did have some limitations. One challenge we found is that in many cases, toxicity is difficult for the model to detect. Comments can be obfuscated in an attempt to trick our model, for example, using misspellings or emojis. Our CNN models particularly had problems with these types of comments, although transformer models often do better. Comments may also use code words or contain microaggressions. This is still an area of focus for our team to research. In many cases, pre-trained transformer models like BERT worked where our CNNs did not. We were alerted to some of these cases by the DeepMind team, who was able to build an adversarial model to trick our classifiers. For example, the sentence on this slide was given a score of 0.99 by our CNN. However, our BERT model gave it a more reasonable and lower score. We had also seen that quality was lost in distillation. In particular, our CNN showed worse bias characteristics than our transformer models, which is reflected in our metrics. We could also see that our performance on new data wasn't as good as we expected. While our performance on legacy test sets like civil comments remained high, our model did significantly worse when evaluated on new comments that had been recently sent to our API. At least one reason for this could be that language and discussion topics on the internet evolve. For example, our English model was built before terms like COVID-19 and QAnon gained widespread usage. Our last generation of CNNs were monolingual models, trained on data from only a single language. When comments were sent to our API, we used a separate language detection model to decide which monolingual CNN to use. However, language detection is not perfect and can sometimes get confused by misspellings. This would result sometimes in comments being sent to the wrong language model or our API returning an error that incorrectly said that the comment's language was not supported. We also know that many users mix language or code switch, often within a single comment. Monolingual models don't offer support for this use case. Lastly, building and maintaining one model per language was a lot of work for our software engineers. Adding new language support has been very important to our team as a way to make Perspective accessible to more users. However, adding languages in our old design was not easy. Our old models were limited to a fixed vocabulary, even for the transformer model. Language and vocabulary change quickly online. However, regularly redoing pre-training on our transformer model to pick up new vocabulary was expensive and not realistic. We could also see that low-resource languages were not sufficiently covered by our pre-training data, which limited how well our distilled CNNs could perform, even with new labeled data. These problems were especially severe for character-based languages like Japanese and Chinese. These languages are difficult to cover with a static vocabulary like the ones generated from WordPiece. We also lack sufficient pre-training data for these character-based languages. Even though we had built better BERT models, we could only serve our CNNs. Our customers require low latency, especially for use cases like authorship feedback, and BERT serving times on CPU were just not acceptable. At times, BERT models could take over 1 second per comment. At the time, TPUs for serving were also scarce.
My name is Alyssa, and I'll be presenting a new generation of Perspective API, efficient multilingual character level transformers. Our new generation of Perspective models include 4 key points. English has dominated the modeling of offensive content online. As such, we prioritize the investment into new languages, with a particular emphasis on the character-based languages omitted in Perspective v1. 2, we forged a collaboration with Google Research on a unified toxic comment classification or UTC system. The UTC system includes a single multilingual token-free transformer model architecture, and of note, has no static vocabulary. Third, we have been developing methods for evaluating multilingual models that expand upon the simple metrics used in the monolingual models previously. Finally, we've been investing in resources for serving a much larger model. The new language support includes expanding the corpus of unsupervised data to account for a larger coverage across languages. Specifically, we sample the pre-training equally from 2 sources. The MC4 dataset, composed of multilingual T5 data scraped from Common Crawl for 101 languages, and the Perspective pre-training corpus, a proprietary set of 4.6 billion messages from a variety of sources, including the Perspective API. New language support includes the expansion of supervised data used for fine-tuning. Comments in over 20 languages were sent to raters to assess toxicity. In addition, improvements to infrastructure for scraping bias mitigating data were made so that we would have coverage for the new multilingual sets. UTC, or Unified Toxic Comment Classification Framework, includes 3 components: learnable tokenizers to avoid a static fixed vocabulary, reconfigurable sequence-to-sequence transformer architecture, and a new comment-based pre-training scheme. Our UTC framework utilizes state-of-the-art Charformer encoders employed with gradient-based subword tokenization. Charformer does not rely on a rigid subword tokenization algorithm, but rather learns byte-level tokenization in a data-driven fashion as part of the end-to-end model. In other words, there is no static vocabulary. Pre-training utilizes a sequence-to-sequence or encoder-decoder architecture that is optimized by teacher forcing. We found this to be more effective than a burst-based or encoder-only pre-training. Similarly, the model consists of a reconfigurable encoder, or in other words, during certain tasks, we may remove the decoder for specialized regression or classification heads while retaining a universal encoder for all tasks. The team found adding regression heads to be more effective in practice than the straight T5 architecture. The Charformer Deep Transformer model was introduced at ICLR 2022 by our colleagues at Google Research. To deploy the UTC framework, we needed to invest in serving infrastructure. In the end, we ended up using TPU, devoting almost 1,000 times more resources per query so that we could serve a single, large multilingual model. In addition, we upgraded our serving infrastructure to serve such models at scale. Results. In this section, we will touch on some of the new evaluation techniques that expand upon the in-domain metrics previously used in Perspective V1. We start with the multilingual performance of the UTC model. We assess the new model and the new languages incorporated into the UTC framework against strong baselines, including MT5, base and small, a custom MBERT, and the original Perspective API. The large UTC model outperforms in almost every language with an average gain of over 8%. The multilingual performance of the UTC framework was further evaluated using Jigsaw's multilingual toxic common challenge dataset from Kaggle. The UTC model outperformed all the previous baselines. It was only marginally lower than the number one Kaggle result. The number one Kaggle result employed ensembles of XML Roberta models. At over 5 billion parameters, the top result would not be servable in production. To assess whether our new UTC framework is introducing unintended bias into our multilingual model, we employed the same valuation metrics as Perspective V1. We have taken here a subset of identity terms and translated it across all the languages in the initial UTC model. There are some problems and room for improvement, notably in Korean. However, the initial results were promising. We continue to evaluate the UTC multilingual performance on out-of-domain datasets. One such dataset was the Hate Mochi test suite presented at NACL 2022. The test set included swapped identity terms from comments that employed emojis to make a toxic or non-toxic point. The UTC model strongly outperformed baselines. We also evaluated the UTC model on the multilingual hate check dataset. This work is presented at the WOAH workshop at NACL 2022. The results show that our UTC model outperformed the old Perspective CNN models for every language present, with an average overall of 0.82 AUC compared to 0.68 previously. The Civil Commons Wilds dataset was also evaluated with a small UTC framework. This benchmark used the Civil Commons dataset looking for distributional shifts between identity subpopulations. Again, the UTC model demonstrated the smallest gap between identity groups. One of the hypothetical advantages of the Charformer model employed in the UTC framework is the ability to bypass intentional or unintentional obfuscation. To test this hypothesis, we created a simple rule list seen above and employed it at various percentages on comments. In the box, you will see the same comment with 0 to 50% obfuscation of letters. Our synthetic obfuscation evaluation task showed strong performance for the UTC framework. Our UTC model outperformed the Perspective API, a custom BERT model, and MT5 at every percentage rate of obfuscation. Another theoretical advantage of having a single large multilingual model is the ability to code switch. To evaluate our UTC framework, we assessed comments with 2 or more languages, as shown in the examples above. We created 2 data sets that were composed of exclusively multilingual comments. The UTC large model substantially outperformed all the baselines in all instances. We also evaluated outside of the theoretical, employing real-world comments sent to Perspective API over the last few months. Our in the wild evaluation used a data set of these real comments randomly sampled and showed modest improvements over the old Perspective API for English. As a sanity check, we evaluated individual examples of covert toxicity as outlined in the challenges section of this talk. As shown in the chart below, obfuscation, misspellings, and emojis generally performed much better with the UTC model. However, code words and microaggressions require further work. As a result of our investment in the UTC framework, the Perspective API was able to launch in 10 new languages in the fall of 2021, including in several character-based languages such as Korean and Japanese. Our collaboration with Google Research has also culminated in a paper being presented at KDD in August of this year. Next steps. We are continuing to expand language coverage in the Perspective API to meet user needs across the globe. In the meantime, numerous areas of improvement still exist. These include investigations of bias within language models and annotation, how to assess gaps in performance within single large language models, investigating smaller architectures for lower latency in serving, and active learning to determine which training data is the most helpful in building better user comment toxicity models.
So now to switch gears a bit, we're going to talk about Harassment Manager, which is a tool we built to empower users who experience online harassment. Now, as we saw with the previous presentation, Perspective API is a powerful tool for detecting toxicity in comments, and it's been particularly helpful for moderators and platforms in combating online toxicity and harassment at scale. But this is really just one approach to our broader goal of creating a safer environment for online conversations. And what we've heard over and over again from users and collaborators and other folks we work with is that there's this strong need for tools that support individuals who experience online harassment. And so Harassment Manager is a web application that aims to empower users to document and take action on abuse targeted at them on online platforms. Now, to take a bit of a step back here, most of us understand and agree online harassment is a significant problem, but recent research really kind of puts this into perspective, where we see that 92% of US adults actually agree that being harassed or bullied online is a problem, and 41% of them have actually experienced harassment themselves, with 25% experiencing severe or sometimes even multiple forms of online harassment. And what we also see is that the majority of online harassment involves social media, with then smaller percentages on discussion sites or messaging apps, and about 41% spanning across multiple venues. And we also see that certain identities are harassed more than others, with both people of color and women disproportionately harassed online. And so, with these statistics, we knew we wanted to be really thoughtful when we thought about designing a tool or some kind of solution to help tackle this issue. And so, to do that, we broke this down into a 3-phase, 9-step program to really understand the landscape of online harassment, hone in on user needs, and really take the time to evaluate our concept. And so we started by trying to humanize the problem as much as we could. And that involved one-on-one interviews with journalists and civil society members that we've worked with in the past or had some kind of connection to. And we also tried to understand the landscape as much as possible. And we leveraged our networks, again, with journalists and NGOs through focus groups and other other means of research for us to, again, understand what does harassment look like for folks, what are some of the issues with managing that online harassment, and what are maybe some opportunities for us to help alleviate some of that burden. And so after some of this research work, we ran user hats workshops where we tried to delineate and sort of define the different audiences that may use a tool like this. And we then ran a critical user journey workshop to really map out what might the user journey look like for a tool like this. We then ran a participatory design workshop where we invited folks to actually design what the solution could look like. And then we went through concept evaluation where we again ran the concepts that we had created by the same folks that we had worked with to design and better understand the landscape with. And we also ran emotional well-being research to understand the emotional tax that a tool like this might have for users. And eventually we ran prototype evaluation with the tool that we built to really understand how this performs in the wild and get real true feedback from the folks experiencing online harassment. And so this process really kind of broke down into 4 steps of research, design, building, and evaluating. And this wasn't always a linear process, but we did go through several cycles of this where we, really use the insights from each stage to inform the next. And after a few cycles of this, we landed on what we call Harassment Manager. Now, this process produced a lot of insights and a lot of research, but there were 2 focus areas that we felt particularly stood out for us. And the first was a focus on documentation. Over and over again, we saw that users were already documenting their abuse in some capacity, whether it be taking screenshots, copying, pasting, and just creating some kind of report for themselves. But we also saw that this was a really manual, difficult, and emotionally taxing process. And we also heard that existing tools really tend to consider the individual comments or individual pieces of abusive content, but not really the full story of harassment, including harassment that might span across time periods, harassment that might span across multiple users, or even the cumulative effect of content that may not seem too problematic on its own, but can actually be incredibly traumatizing or emotionally taxing when you see them at scale. And we also felt like documentation was a small piece of the overall problem that we were equipped to tackle technologically as a small team ourselves. The second focus was on female journalists and activists in non-free countries. And so these groups or identities are already particularly at high risk of experiencing online harassment, again, because of the nature of their identity, their work, or the region that they work in. And this necessarily creates a fear around publishing and silences voices that, are important to the ecosystem. And so because of Jigsaw's position in our past collaborations, we were actually also uniquely positioned to work with these folks because we already had many networks and connections with folks in these spaces. And so with all that, I'm going to turn it over to Rachel to discuss what we built, some of the challenges we faced when we tried to build this tool, as well as sort of our future goals and plans with this.
Thanks, Lucas. Now I'm going to talk a little bit more about what we built and some of the challenges that came up along the way. So here you can see the homepage for the tool. It has some general information about what the tool does and how you can use it to document your harassment. It shows a Start with Twitter button, so you can log in with Twitter, who we partnered with to build this tool. Next, we have the homepage where you can see what comments you have from today. These comments are split up into 3 buckets from different levels of priority. These are based on the toxicity scores from the Perspective API. And the options are high priority for Perspective scores greater than 0.85, possible priority for Perspective scores between 0.6 and 0.84, and unknown priority for scores between 0.4 and 0.59, which is sort of the center range for Perspective, which remember, because Perspective API gives a probability score, means that the model is really not sure whether the comment is toxic or not. For the high priority box, you have the option to add all comments to the report without looking at them. So this is meant as a feature that could allow someone to potentially not have to look at harassment. And we only offer this for the high priority box because we are more certain about the toxicity of those comments. But we also allow users to just look at all the comments if they want to look for something specific, or they don't want to use the predefined buckets that we've displayed. So next is the Create Report page. On this page, we have a number of things. So I'm going to start with the main thing on the screen, which is the comments in the center. So these show the comments you've received from whatever bucket you have clicked on from the homepage. And so it displays the likeliness that the comment is harmful, whether or not it was a popular comment. So that means like high engagement. So things like retweets, likes, replies, and then how long ago the comment was posted. So you can assess whether or not it was recent. Next, on the right, we have the actual content of the comment. As you can see here on the screen right now, the text is blurred, and this is the default setting. The reason for this is that because we don't want to, have the harassment right in the user's face when they first load the page. We want to make sure that they're prepared to see it before we show it to them. And the current behavior is to display on hover or to click the show button under comment preview, which will show all content. This also blurs images that come with tweets. So you can, you don't have to see any of the content of the harassment without checking first. We also display some user information about the user who made the tweet. You can also expand these boxes, which allows for seeing some more metadata on the Perspective API scores for each of the model attributes we offer, as well as the specific engagement metrics for the post. There are some filters we offer here to allow you to more easily paginate between comments. So in this example, we just have 2 comments we're displaying, but in a real example, user is likely to have quite a high volume of tweets, especially if they have a very popular account. So we allow the user to search for specific terms. We also allow you to specify the time range that you want to select. So this can be anything from 1 day to a month to any custom range that you like. And you can also select what levels of harmful you want the comments to be. So this corresponds to the toxicity levels of the comment. So we specify, comments that have, high likelihood to be harmful versus comments that have low likelihood. You can select some or all of those. We also allow filters for things like images or whether the account is verified. And once you've decided what comments you'd like to include in your report, you can click the checkbox on the left-hand side, and that will add the comments to your report draft. And then you can click the continue button to see the rest of the report. So on this page, you have the edit details page, and this allows you to provide a little bit more context on the harassment in your report so that anyone looking at it can understand why you're submitting this report, since not all reviewers may understand your specific circumstances. So we have on the left-hand side, we just have a summary presented for you if you're curious about what users were leaving comments in your report and how many comments they left. Maybe you're being targeted by a specific user. You can also select the type of harassment that you were receiving. So these come from typical fields in a harassment report on a website. And then additional notes is any other context you want to report. Maybe you're getting harassed across platforms, or maybe one particular user is targeting you, or the specific message that's being sent, while it sounds innocent, may actually have other undertones that might not be obvious without some more context. And then when you're done adding context, you can click continue, and this will bring you to the download report and take action page. And on this page, you can see a report of all of the comments that you have selected along with the context. And you can also take some actions here. So some of the options here are you can block or mute the accounts from the users who left the comments in your report. And you can also use the hide replies function on Twitter. So this will only impact direct replies to your tweets. You can also save a local copy of this report if you just want to document and don't want to take any actions. And then when you're done, you can click close report. At this point, you're going to see a prompt asking you whether you're sure that you're done, because we will delete the report draft once you confirm. And we do this for user privacy reasons. We know that a lot of users are concerned about storing their data, and we want to make sure that we only hold it for as long as it takes for the user to complete their report. Next, I'm going to talk about some of the challenges we faced while building this tool. So the first challenge is the limitations of machine learning. So like I mentioned before, we use Perspective API to help prioritize content based on its toxicity score. However, Perspective is not 100% accurate, and it's actually not possible for any machine learning model to be. Additionally, harassment is constantly evolving and unique to the individual. So the toxicity score may not perfectly match the type of harassment that the user is experiencing. Next, we cannot fully automate this process. So in addition to the fact that models don't perfectly match every individual's harassment story, we also have the fact that harassment is often a story. So you need to have information about when it started, who is harassing you, why they're harassing you, are they harassing you across platforms, and things like that. And to be able to add this context is crucial to help explain what's going on. Additionally, there are no APIs for reporting harassment, so we couldn't add that as part of the tool. So instead, we use existing APIs like blocking and muting, so users can take available actions to make their experience better. Last is that harassment can be ambiguous. While there are clear examples of harassment, some examples are not so clear. Examples are charged political speech, counter speech, and positive trolling, where several people might disagree on whether a specific comment is harassment. Lastly, harassment does not always violate a platform's terms of service for the reasons above that it can be ambiguous. And as a result, we might have a policy on one platform that states certain things are harassment and a policy on another platform that may be different. So it's hard to make this universal. We also had to design around the fact that the experience could be emotionally taxing. Whether you're reliving harassment that you have already experienced or whether you're discovering it for the first time, this can be traumatizing. So the tool blurs comment text by default, and we also blur images, and it stays this way until the user specifically specifies that they want to see the comment. And in this way, the user is in full control. Additionally, we allow users to log out and back in, and we save their report draft and what step they're on. And this allows users to work at their own pace, so they don't feel like they have to do everything at once. We have also open sourced the code on GitHub, so it's available for anyone to use. This allows organizations to create custom tools with their own branding and features that help their specific users. And in fact, we have partnered with the Thomson Reuters Foundation, who will launch a new tool for their community of journalists very soon. And finally, I'd like to get across that what we're hoping is to inspire a shift in thinking about online harassment. Right now, harassment is often understood in the context of an individual comment, and comments are moderated independently of other comments. But we want everyone to understand that harassment is a story, and we need to understand the full story from the user's perspective in order to fully manage online harassment. Thank you.